Morning. Um, so I'm gonna demonstrate my project as to how far I progressed. I know I've conveyed the general idea to both of you, but it's just I wanted to show you what are the specifics that probably uh, you wanted me to relay. So so far I've come up with the general set of AI through edge detection and how does it control and what are the problems with it? Why am I using edge detection in the first place when neural network is a much better idea? And why not just jump to that area? I'll explain it all. So the whole idea behind the code is that so this is the main code. Let me just close this off. Yeah. So one idea is that I'm drawing two lines. Each line represents like a slope of area that the after masking the image that it captures through edge detection. What it does is that when it captures those images and it puts a blur on it and like finds the similar lines, it combines it like sees the like the similar scope of those lines and then combines them into one. It draws them into one. So each line will be on one side of the screen, showing that it should be on like one area, i.e., that like one line should be on the positive side, one line should be on the negative side of the x-axis. So if both of the lines are either on positive or negative, then they should respectively go left and right. So this part of the drawing lanes part of the code is something that I still have to understand. So through trial and error method, I was able to execute it. There's still some difficulties that I'm facing with it, but I believe that is one of the minor problems that I'll face since eventually we will not be using this algorithm for the end product. Similarly, once I got the image processed over here, this is the masking vertices that I'm using for the image, and generally these are the two lines that are being created with their respective coordinates, the starting x and y axis, the color, which is red, and the depth of the line. So I'm going to use short lines so it doesn't look very ugly per se. And once that is done, we can play the game. We can give it a, I'm going to give it a buffer time so that I can switch between the games and the applications itself. These are the codes. Uh, so there is this key input, which is another code that I borrowed. So it's generally hex keys that are being pressed. Once that is done, which I believe I have showed you in the last meeting. So this is that code. So from there, I'm putting it over here. These are the mouse coordinates. So this was used in masking of the game. So what happened was that I needed to know the exact coordinates to be masked because ultimately I don't really want the full image of the game. Again, another constraint of edge detection. So if I move my mouse, I did track a few points within the game itself. Once I was able to track, I masked that specific image and I went on with the calculations. So this is not really used within the application. It was something that I kind of sort of looked on the internet, created a code of it, and then I used this to calculate as to okay, this is something that I want. Because while the code and the concept of this execution of this application is not fully mine, it's something that I got an idea from or like I borrowed the idea from. I did tweak a lot of parameters so that I could make it more approachable towards what I'm really trying to execute here. So thereby I needed proper or uh, like exact numbers to execute it because first and first foremost thing that I am trying to do different is I'm trying to take a bigger resolution of the game capture that is, and that would probably create a lot more accurate data as compared to the general data that I've captured earlier on during my execution of this project in my bachelor's. And yeah, so right now when I run this, it will give me a 10-second buffer time over here to switch between the application and the game. Then a buffer time over here to create another window where I can show, okay, yeah, this is how the game is gonna run, and probably yes, go a long way to show, okay, yeah, this is what I've been able to execute. I believe sir and ma'am, both of you have advised me to as not to go. I don't know, like you were trying to tell me ki, okay, so I need to narrow it down. So I did narrow it down to the point where I know, okay, this is where the changes are need to be made, and by tomorrow or day after tomorrow, I'll be done with the code and I'll move on with the documentation. After that, once that is done, what I'll do is I'll take the model that was made through the neural network of within the game itself and try to implement that same model through an application on the phone on a Raspberry Pi module if possible or someplace else, something with a camera, something that can register the image in front of it. Then that image that it collects in real time will be processed by the model, and if the model works on the real life images, then my project is successful, my idea is successful. The whole idea behind the project is to show that video games at first were created with inspiration from the real life. Now I want to take that same inspiration but from video games into the real life to show that simulated projects or simulated ideas can be used and do have real life applications, and there are real world examples of this as well, which I'll probably demonstrate later. So I'll move on with the execution of the project. So I'll first execute this. So buffer time over here. This is the main game window that is running on the corner. So that's the main game that I will be running. Okay, now I in the lower corner of the game, which is currently blank right now, is something that I want to show you. So over here, if as you can see, is a loading screen. So the reason it has not loaded yet because the OpenCV loop is not working. So I'll switch to the game because the timer is running out. Within 30 seconds, I'll switch, and once that is done, so yeah. So over here, it's like this, and I believe it will work. I hope it works. I've tried, I tested it out at least 3, 4 times before recording this video, including where I crashed the game once. So within 6 seconds, we'll be there, and it will also demonstrate within the screen itself. Okay. So as you can see, it's I'm not actually controlling the game over here. It's registering the it's turning left, but it's not moving like ahead. So that is something I need to change with the code a little bit ahead. But yeah, so I need to guide it a little, the game itself. Just a minute. Yeah. So I hope it works out. So as you can see, it's running. It's partially running to a certain extent. And yeah, this is where it fails over steep and sharp turns. But at least it's able to run the project. So one of the constraints over here is that the what do you call it? Just let me pause it. So one of the constraints over here, great. Just a minute, ma'am. Just a minute. I need to pause the code. Uh, once I need to fix this again because I believe the image was not captured. Uh, yeah, my apologies for that. This window was not captured over here properly, and I may need to shorten it down a little bit. So, let me fix it again. Let me set up the environment. So this is me playing the game right now. I have not actually generated the edge detection screen because it was taking too much processing power, and there is a lot of more that is beyond my understanding or beyond my knowledge of understanding, which I still have to learn, or I'm currently in the space of learning. Uh, so I'll pause it again. This time, I believe it will work. Just a minute. Oh, great. Uh, so, so as you can see in the lower right corner of the screen, those are the lines, and that's how the game is like working. It's detecting whether to go left. So when both lines are on the left, it means you have to go turn left, which it did not, or at least it tried to, but the speed of the game did not really register the amount of turning that it will do. And it's still going on, it's still giving its mixed data. So this is why such concepts cannot be executed. It's like the partial idea is good, but yeah, uh, the reason I executed it is like I wanted to understand it myself, the constraints itself, and I also wanted to show it to the panel when the day of execution will become coming to an end. Okay, yeah, this is why certain ideas, when executing them to the general constraint, will not be applicable. Hence, this is where the neural network steps in. Uh, and for the time being, this is it. And I hope this demonstration of the project was good enough or like up to your expectations. And I'm really, really eager to hear your words on it or your input on it. Naturally, I hope I will improve upon it. Just give me a minute and I'll turn it off. So I'll stop the recording. Thank you and have a nice day.